Hello, my name is Bhargav Kumar. Now I am going to teach about rotational motion in physics. Okay, I am using a writing pad and a Zoom call. Okay, uh, okay, let's start our class today. I'm going to stop the video, sharing a white screen. Okay, let's start rotational motion. Okay, so before understanding what is rotational motion, first thing we have to know understand is linear motion. Linear motion. So what is linear motion? Any object moving in a straight line is called as is the and that body is said to be in linear motion. Okay, for example, let us consider a mass of a block of mass. Okay, let us say it is moving with constant velocity v on a horizontal surface. Okay, so the important property here for the linear motion is, let us consider any 2 points on that block. Okay, let's say this point is a, this point is b. Okay, so if I go into the point of reference of a, then the point b will be at rest. Okay, so if I go into point of reference of onto the on the ground, point P, okay, then the velocity of A will be same as velocity of P, and it is equal to nothing but velocity of the center of mass of the block. Okay, so all the points on the block will be having same velocity. Okay, this is the property in linear motion. Okay, now let us understand what is circular motion. Circular motion. Okay, what is the definition here? For example, if there is an object O, okay, and it is at, let us say this is a point P, okay, if an object O is moving in a circle around this point P, okay, in a circle, then of fixed radius, then this kind of motion is called as circular motion. Okay, we don't know what is the speed of this or velocity of this, we don't know, but we only know that it is moving along a circle around this point P, then this motion is called a circular motion. Okay, so to understand the rotational motion, why we need to understand these two? Now we will see. Okay. Now what is rotational motion? Now let us say there is a planar object. Okay, of any shape. Let us consider some arbitrary shape. There is a planar object. Okay, this is very thin and planar. Let us like a cardboard. Okay, like an exam pad. Okay. So let us say this point is somewhere on this uh, on this object, planar object, and let us say this is a line passing through it to that point. Okay, this is perpendicular to the board. Okay, that means this is in z-axis and this board is in xy plane. Okay, now let us consider any 2 points on this, any 2 points, point A and point B. Now with the rest, for example, this point is fixed in space. Okay, and other points are all free to move about this point. That means this whole object can rotate about this point freely. Okay, on the same plane. Okay, then with respect to point B, all other points will be in circular motion. Okay, and also with respect to this point will be moving in some other direction. Okay, so all the points are in circular motion. The whole object is said to be in rotational motion. Rotational, said to be in rotation. So this is how we define rotational motion. Okay. So what is a linear motion? Linear motion, if I consider any 2 points on an object, if no 2 points are, if all the points are in same velocity, moving with same velocity in same direction, then that kind of motion is called as linear motion. So if I consider one point, and all other points are in circular motion around this point, then this kind of motion is called as rotational motion. Okay, so measuring rotational motion. Now let us understand about rotation. Okay, to understand rotation, we need to understand few things: one, two, and three. So in linear motion, what are the things we have considered in linear motion? What are the things we will consider here? In kinematics, we consider the distance traveled by the object distance, and we will consider the velocity, and we will consider the acceleration. Okay, distance is how it is defined. Distance or displacement. Displacement is nothing but the final position vector minus initial position vector. Then that we will consider as equal to final position vector s2 bar minus s1 bar. Okay, if I subtract in final and with the initial, then I'll get the displacement vector, distance or displacement. Okay, distance is the scalar quantity, displacement is a vector quantity, but I am considering only vector quantity here. So s2 bar minus s1 bar. Okay, so what is velocity? Velocity is nothing but rate of change of displacement, delta s bar by delta time. Okay, velocity vector, how can we find out the the rate of change of distance or displacement is called as velocity. And what is acceleration? The rate of change of velocity vector is called as acceleration vector. Okay, acceleration is represented with letter A. Now similarly, we have angular velocity, angular acceleration, and angular displacement. Okay, first we will study about angular displacement. Angular displacement, it is represented with letter theta. Okay, now we will study about what is angular velocity, angular displacement. Okay, angular displacement. What is angular displacement? For example, in circular motion, let us say our object is moving around this circle. Okay, and we are measuring our angle with respect to x-axis. Okay, so for example, one object is here at initial position is, let us say this angle is theta 1. Okay, and it is moving along the circle and it went here. Let us say this final angle with respect to x-axis is theta 2. Okay, then we can say that the angle moved by this object, okay, object will be equal to theta 2 minus theta 1. Okay, final angle minus initial angle, which is same as final displacement minus initial displacement in the linear displacement concept. Okay, right. So delta theta, which is equal to angular displacement, change in angular position. You can also say it as angular displacement or change in angular displacement or change in angular position. All are same as angular displacement. So angular displacement will be equal to final angle minus initial angle, right? So now we will what is the now angle is measured, can be measured in theta, degrees or radians. So what is the um, relationship between 1 degree and 1 radian? 1 radian will be is equal to, or pi radians will be is equal to 180 degrees. 180 degrees. That means in a straight line, if I see this angle, this is 180 degrees. This is nothing but pi radians. Okay. In a circle, circle, we have 2 pi radians. This is pi radian, this is another pi radian. So total angle will be 2 pi radians. 2 pi radians. This is equal to 2 pi. Wait. 2 2 pi radians equal to 360 degrees. Okay. So this is the relationship between pi radians and 180 degrees, and this is the definition of angular displacement or change in angular position. Okay. Now, what is the second one? Second thing to understand about rotational motion will be angular velocity. It is represented with letter omega. Okay. So now we will understand what is angular velocity. So angular velocity. So what is linear velocity? It is defined as change in angular change in linear displacement with respect to time, or rate of change in angular displacement. Linear displacement is known as rate of v is equal to delta s by delta t. We already studied this formula. Where change in displacement with respect to time, or rate of change in displacement is known as velocity. Okay. So here change in uh, change in angular position with respect to time is nothing but angular velocity. Okay. So what is angular velocity? Final angular position minus initial angular position by the time taken in this change. Okay, whatever the time taken in this process of changing angular position, that time is this t. Okay, if I divide the final position minus initial position by the time taken, then I'll get angular velocity. Okay, so this is nothing but in a over a period of time. Okay, let us say 10 seconds. In 10 seconds, let us say it underwent a change in angular velocity of change in angular position as 200 degrees. Okay, then we can say that angular velocity of that object will be equal to 200 by 10. Okay, that is 20 degrees per second. Okay, so to convert this to 20 degrees into seconds, what we will do, we will use pi radians is equal to 180 degrees. Okay, now what is 20 degrees? Okay, that is nothing but pi by x is equal to 180 by 20, that is 9. Okay, so x is equal to pi by 9. So this is nothing but pi by 9 radians per second. So this is how we will calculate it, right? So this is the definition of angular velocity. This is uh, over a period of time we will calculate like this. But if I want instantly at every instant, if the angular velocity is changing, okay, that means this time interval is getting slower and smaller and smaller, and this change in angular velocity is also angular position is also getting smaller and smaller. Then how we will calculate? So instead of getting instead of taking capital delta, we will take small. We will d theta by dt. Okay, this is nothing but differentiation of theta with respect to time. If I do, then I will get instantaneous angular velocity. Okay, so in linear concept, we already know that instant velocity will be equal to ds by dt. Okay, here it is d theta by dt. So that is the concept of angular velocity. Okay, now we will understand what is What is the third one? Third one, what is it? Angular, sorry, angular, angular acceleration. It is represented with letter alpha. Okay. So what is the definition of linear acceleration? Linear acceleration is defined as rate of change of velocity. Okay, rate of change of velocity. That means change in velocity with respect to time is nothing but rate of change of velocity, which is nothing but acceleration. Okay, here same definition can be applied to the angular acceleration concept. Okay, now we will understand what is angular acceleration. Third one, angular acceleration. Okay, so what is angular acceleration? Angular acceleration alpha is nothing but change in angular velocity with respect to time. Okay, so delta omega by delta t is nothing but angular acceleration. This is nothing but omega to final angular velocity minus initial angular velocity by time taken. Okay, so similar to the angle instantaneously, if I want to find if it is constantly changing, omega is constantly changing with respect to time, then if I want instantaneous angular acceleration, then it is nothing but d omega by dt. Differentiation of omega function, that means omega is changing with respect to time with some function. Okay, some function. Then if I differentiate that function with respect to time, then I will get alpha. Alpha is nothing but angular acceleration. Angular acceleration is defined as rate of change in angular velocity is called as angular acceleration. Okay, what is the unit of it? So omega's unit is, what is the unit of omega? Angular velocity is defined as theta by time. So it is degrees per radians. We have discussed this, or radians per second. Here it is, what it is, degrees per second. Okay, d omega is degrees per second. Change whatever will be same as degrees per second, and by time, that is nothing but degrees per second square. But degrees is not considered as a basic unit, or radians is just a number. Radian or degree is just a number. So we will directly write as 1 by second square. Okay, there also we will directly write as 1 by second. Omega's unit is nothing but 1 by second. Okay, degrees and radians, those are just numbers. Okay, pi is a number. 1 degree means we can calculate it, 1 360 by pi, that is the number. Okay, so these are the concept. Now we will understand what are the relationship between these three quantities. Okay, so in linear velocity concept, we have already know that those three kinematics equation, there will be three kinematic equations, right? One is v is equal to u plus at. Okay, so similar to this, sorry for the sound. Okay, so there is construction going on in our upper floor. Okay, let's continue. Okay, similar to this equation, if I want a final angular velocity, let us say it is omega 2. Okay, lb is equal to initial angular velocity omega 1 plus alpha, which is, instead of a I am using alpha. Alpha is nothing but angular acceleration, time is time. Okay, so final angular velocity will be equal to initial angular velocity plus alpha into time. Okay, so second equation, what is it? S is equal to ut plus half at square. Okay, what is S here? S is the linear displacement, u is the initial velocity, a is the acceleration, linear acceleration, and t is the time taken. Okay, So similarly, if I want angular displacement theta will be it is equal to initial velocity omega 1 into time plus half into alpha into t square. Okay, alpha is angular acceleration. What is the third equation in kinematics? V square minus u square equal to 2as. Okay, so analogous to that, omega 2 square minus omega 1 square will be equal to 2 into alpha into theta. Okay, so these are the three equations which are just derived like this. Okay, these are the three equations we have to remember to solve the angular kinematics. Okay, rotational kinematics or angular kinematics we can call it. Okay, these are the three main equations. Okay, now let's do one problem. Okay, okay, I will read one problem. A motor of an engine is rotating about its axis with an angular velocity of 100 revolution per minute. Okay, 100 revolution per minute. There is one motor, and it is an axis. It is moving. It is rotating with 100 revolutions per minute. Okay, and it comes to rest. It comes to rest in 15 seconds after being switched off. Okay, after being switched off, that means like a fan, if I switch off, it came to rest after some time, and that time t will is equal to 15 seconds. Okay, assuming constant deceleration, calculate the uh, calculate the number of revolutions made before it came to rest. Okay, number of revolutions we have to calculate. It is already given in revolutions per minute. Okay, number of revolutions we have to calculate before it came to rest. Okay, we have to assume it as constant deceleration or angular deceleration. Angular deceleration. So we have what angular deceleration we have to assume. Let us say that angular deceleration as minus alpha. Okay, alpha is a positive number, minus of it is a negative number. Okay. Okay. Now which formula we can use here? We have to calculate what total angular displacement we have to calculate. Total number of revolutions means we have to calculate total number of angular distance we have to calculate, and we have time, and we have initial angular velocity, and uh, we have to find out this. Okay, so which two formulas we can use? We will use this formula and this formula to solve this. Okay, so omega 2 is equal to omega 1 plus alpha t. Okay, here alpha means minus alpha we are assuming. T is 15 seconds. Omega 1 is nothing but 100 revolution per minute, and final velocity omega t is nothing but 0. That thing we have to observe. Omega 2 is equal to here 0, and omega 1 is this much. Okay, now we will substitute here. 0 equal to omega 1 is 100 revolutions per minute. Whatever the answer we are getting, that will be also in revolutions per minute square. Okay, but instead of 15 seconds we have to give it in minutes also. Okay, plus or minus here, this alpha is our alpha is minus alpha, and t is 15 seconds. Okay, 15 seconds in minutes, what it will be? 15 by 60 minutes. Okay, so whatever the answer we are getting, we will get in revolution per minute square. Okay, now here what is alpha? Alpha 100 is equal to alpha into 15 by 60. So this implies alpha will be is equal to 100 into 60 by 15. This is 15 460. This is 400 revolution per minute square. Okay, now found out alpha. Now we have to find out, we have to use this formula and we have to find out theta. Okay, omega 1 is 100. Okay, t is 15 seconds. That means we have to give it in minutes again, and alpha is 400. Now then we will get as theta in revolutions. Okay, now we'll substitute that. What are the things we have to remember here? Alpha is equal to what we get, minus 4. Alpha we found as 400, but minus alpha is the deceleration, so this angular deceleration will be minus 400 revolution per minute square. Okay, omega 1 is 100 revolutions per minute, and time is 15 seconds, which is nothing but 15 by 60 minutes. Okay, these are the three things we know. Now we have to use the formula. Theta is equal to omega 1 into t plus half into alpha into t square. This is equal to, what is omega 1? 100 into, what is time? 15 by 60, minus, here instead of alpha I'm putting minus 400, so that minus I'm writing here. So half into 400 into, what is time? 15 by 60 into whole square, right? So 15 by 60 I'm writing 2 times. Okay, time square, 15 into 15, 60 into 60 whole square, right? Okay, clear? So this is nothing but angle. If I calculate this, then I'll get the answer. Okay. So this is 4 times, this is 25, and this is 200. This 0, this 0, this 0, this 0 is gone. So this is 2 threes, 3 fives. Okay, so this is 3 twos, 3 fives. So 25 by 2, 25 minus 25 by 2. So theta is equal to 25 minus 25 by 2. This is nothing but 25 by 2 revolutions. So this is 12.5. 12.5. After 12.5 revolution, it will come to rest. Okay, understood, right? So this is how we will use these formulas. What are these formulas? Yeah, these three formulas we will use and find out like that. We can also directly use this formula also. Okay, final is 0 and initial is omega 100, and alpha we found as uh, what is it? Alpha we found as, what is it? Alpha 400 or minus 400, right? Minus 400 if I substitute here, then we can find out theta. So any of the these two formulas I can use in the second step, but for to calculate the alpha we will use this first step. So this is how we will do the problems. Okay, so I'll stop the class here, right?